Hello everyone, I'm Roan, creator of Our Fantasy, a multiplayer action RPG with tabletop-style roleplay. But I'm not here to talk about that. I'm making this video because I noticed, while working on my game, that there was a lack of tutorials for a common feature, adding a turn radius to a character's movement. It's such a simple thing, and I think that's exactly why it's overlooked. For the sake of posterity, I'll be making my own tutorial. The logic for adding a turn radius to a character blueprint is fairly straightforward. By default, a character has the desired direction applied to the actor as a vector, and then the actor's rotation adjusts at a limited rate to match. To get a turn radius, you want to invert that process, so that the desired direction is applied to the rotation at a limited rate, and the actor's movement is simply applied to its forward vector. For this tutorial, we'll be using the default character blueprint, BP underscore third person character. It's the one whose skeletal mesh is delightfully named Manny or Quinn, depending on your persuasion. Open it up and start by creating a new IA move event and unplugging the existing one. From there, we'll want to get our camera boon component and get its world rotation. We will also need the IA move values, that's the X and Y axis of the joystick. We could get these values from the event node itself, but to keep things clean and easy to read, we'll use this little one instead. Event value nodes like this one can be created anywhere, even when the event itself isn't called. Next, I'll right-click and split struct pin so that I can access the values individually. I'll be doing this repeatedly throughout this tutorial, so if you ever see one pin explode into multiple, that's why. Go ahead and drag out the absolute value of these pins, and set them aside for later. Next, drag out the IA move's X value and find its sign, which we then multiply by 90 and add to the camera's yaw. Make a new rotator with the sum as the yaw. Next, we get the Y value, get its sign, and get the minimum between it and 0. We then take the absolute value, so that the result is either 1 or 0, telling us if the stick is held backwards or forwards respectively. We then multiply that by 180, add it to the camera's yaw, and set that as the yaw of a new rotator. I'll name these nodes forward rotator and right rotator, just so I don't get them confused. You can name a node simply by clicking on the little white bubble that appears above it when you hover the mouse over the node. Now we need to process the information we've just created. Take the forward rotator and plug it into a lerp rotator. Be sure to plug the forward rotator into the A pin and the right rotator into the B pin. Now we simply add the absolute value of X and Y together, and divide the absolute value of X by that sum. You could divide Y by it instead, but you'd have to swap the A and B pins around. Take the result of the division and plug it into the alpha pin of the lerp rotator, and be sure to check the shortest path boolean. If you don't, the character sometimes won't rotate the way the player intends, or at all. We're getting close to the finish line. Next, we need to create an rinterp2 node, and plug the lerp into its target pin. For the current pin, we simply get the actor's rotation. I, however, am always paranoid when it comes to rotators in Unreal. To prevent any oddities where the roll or pitch gets offset from 0, split the actor's rotation and then make a new rotator with just the yaw. This won't work for every project, like if you're making a game that features flight or deep sea swimming or something. For those types of projects, just don't zero out the pitch and yaw like I keep doing. Next, for the delta time pin, we simply plug in get world delta seconds. This will ensure that the rate of rotation remains fixed relative to the tick rate of the game. The rinterp speed is where we set the turn radius of our character. First, we'll pull out a max node as a precaution, and set the bottom value to 0.000001. That's 5 zeros and a 1. The smallest value Unreal accepts before rounding down to 0. The reason for this is that the rinterp node throws an error if the speed input is 0, and produces weird results if it's negative. Given the math we're about to do, it is possible for the input to be 0, so this step is necessary. As for what to compare against, we simply take the sum of the absolute of x and y and multiply it by a new variable I'll call turn radius. This number should be smaller than 1, and the smaller it is, the wider the turn. For now, I'll set it to 0.05. Now that we have our new rotation, all that's left to do is to set the actor's rotation to it, and then add movement input. The world direction is the forward vector of the rotation we just made. Since we just set the actor's rotation with the same data, getting the actor's forward vector is also valid. The result will be the same. Lastly, we just need to set the scale value of the movement input, which will be the sum of the absolute value of x and y. Okay, now just click compile and... oh dear. Okay, so I forgot to adjust some settings. First, you'll want to set your camera boom's rotation from relative to absolute, and then turn off use pawn control rotation and inherit pitch, yaw, and roll. Then, change the camera input like so, setting the world rotation of the camera boom with the IA look event. I multiply the input by 0.2 because the default is too strong for me, personally. And now, as you can see, we have a limited turn radius. These circles, shown in red, are the tightest I can manage, and if I change the turn radius variable to 0.01, the turn radius gets ridiculously wide. I mean, look at that. It's like I'm an 18-wheeler or something. I hope you found this helpful. If you have any questions, please feel free to leave them in the comments. And one last thing before I go, I'm making an action RPG/TTRPG thing called Our Fantasy. I have a Blue Sky and a Patreon where I post regular updates about my progress, links in the description. For now, there aren't any rewards on my Patreon, but all the content is free to public view, so it doesn't hurt to take a peek. Alright, that's everything. Bye!